Hello, and thank you very much for being here today. The idea today is to tell you a bit about how we can implement AI solutions in the supply chain, and I hope you find this presentation useful. Well, first of all, I want to tell you just a bit about Aquiles, our company, where we basically develop AI solutions for different things. And today we will mainly talk about the central piece that you can see here, business processes, but I also would like to introduce you a bit about what we do in the other areas. Basically on strategy and data, we help different companies to take better decisions based on advanced analytics that has to do mainly with dynamic pricings and demand forecast and so on. And then we also do digital transformation, which basically we go together with the customer to give them training and make sure that they move their teams according to what is needed for the digital transformation of the company. Okay, but today basically it's business processes. So, and I will do a main focus on the artificial intelligence applied to the supply chain. Okay. So first of all, what is a good solution in supply chain? Well, we consider that a good solution should have these four different aspects. First of all, it needs to be automated. So what we want is basically to make sure that the company we can have our people focus on the core business. So therefore, we want the systems to run in autopilot and make sure that the systems run properly. So your people don't need to be focused on things that can be done by the machine. It also needs to be optimized. That means that we're trying to find the best solution to a specific problem. I'll give you some examples, but it's not something that we can only do with machines. I mean, you can have a person trying to figure out which is the best solution. Now, the beauty of doing it with artificial intelligence is that we are actually able to get to that best solution much quicker than by other means, and we are able to repeat that iteration once and again whenever there is any data that changes, right? It also needs to be intelligent. So the AI actually helps us classify different things or discover hidden patterns in the data, which is something that we would not be able to do in other ways sometimes. And I'll specifically talk about an example where even the classification is not obvious that it can be done with other means, right? And finally, it needs to be integrated. This means that the system that is running with AI needs to be integrated in the rest of your digital ecosystem. Otherwise, you will end up having an island that would be good, but if it's not connected to the rest of the things, and especially in supply chain, that would not provide the efficiency that we are trying to achieve on the systems, right? Okay, so let's jump into the examples. Well, I'll give you one example which is related to the customer area. So starting the supply chain with a customer that is putting up some requirements of what we need to produce. Then, of course, we need to source some material. Okay, that will also come with another example. I'll tell you now. After that, we are planning our operations, and we need to make sure that we can do the things in the way that we need it and do it efficiently also. Then we go, once we have planned that, we jump into the production and produce the thing that we are supplying. Okay. And finally, we have logistics to bring that to the end customer. Okay. So I'll give you one example on each of these 5 different areas of real projects that we have executed, and I hope that will actually inspire you to think on potential things that you could do on your companies, right? Okay, so first of all, on the customer area, well, here the context of the project is that we are working with a B2B company that receives many orders. They have an online store, but it's not used as much as they would like to, and they also have EDI integrated with some customers. Now the thing is that many customers receive the order on their own format. So that means they send a PDF through email or a Word or whatever. And the thing is, well, what is the problem is that the orders are actually entered manually by back office staff. There are possibility of human errors, and they actually have quite a few people in the back office dedicated to these things. that they could actually use their time maybe on other tasks like supporting the customers on figuring out where their order is, if they're going to receive it on the right time, and so on and so forth. Right? So what can be done here? Well, one thing that can be done is what you can see here on this video, which is a system that actually reads from your email the different PDFs that you receive. You're actually able to select the information with a table, and from that table, the system recognizes what is the product, what is the price, what is the reference. You can introduce the order number, and that is pushed directly into your ERP system. Okay. Now, this is what you can see here is done manually, but you can also automate the whole thing. So basically, you can say, the system is reading the email automatically, and if the prices are correct, if the products are recognized, if the discounts are applied are the ones that you have in your ERP, and so on, then the order is automatically produced into your ERP. If that's not the case, then the operator will get a warning saying, look, I have tried to process this order, but I'm not able to process 100%. So please go into it and check what is wrong or correct whatever you need. And then that system, that would just transfer it to the ERP once it's ready. Okay. So how that is done? Well, basically what we do is we identify objects that create different line items, as you can see here. So, and what we do is have, through artificial intelligence, identify what is what. So because of these codes have some codes at the beginning, this is most probably a code, right? Now, this seems to be the amount. Why? Because if I take the units and I multiply by the price and I apply the discount, then I'm getting the amount. And this is the logic that we are trying to apply to this text to actually come up with the different, to understand what is what, right? It can also recognize the text. And if you have your text described in your ERP, as you probably do, then that would actually do the match also. It also works in case you have the customer is putting a code which is not your code, but is his code. Okay, that can also be recognized. But at the end of the day, this is providing good, reducing the errors and making sure that your people can spend the time on doing something else. Okay. Okay, good. So that's the first example for the customer. So now let's look into the materials. In here, the idea is that we're trying to use image to recognize different materials. What is the context? Well, we're working for a steel company which has different types of scrap, and each type of scrap has a different price. And the problem is that right now this is being done by people that once the trucks arrive to the plant, that person is looking into the pile of scrap and deciding which type of scrap is which, and how which is the percentage of each of the scraps in the pile. Okay. Now scrap. Well, there are different types of scrap. You can see here 4 different types of scrap, which in here you can see like full piles with the same type of scrap, each of them. But many times on the tracks, this scrap was mixed. It's mixed, right? And therefore, it's important to understand which is the percentage of each of them that can be seen on the images. So what was done here? Well, basically, the customer had a lot of images already classified because each time they had images for several years, and for each of those images, we knew which was the percentage of each of the type of scrap, and that's because when the tracks were unloaded, the classifier who was doing the classification was also taking pictures. So we know in the system which classification was done, and we also have the images. So with that, we trained a convolutional neural network, which actually allowed us to predict the classification for a new image. So once that was trained, we were able to say, okay, this is the new image. Now please tell me which is the classification that we have. Okay, and as you can see, what we did is on the images we split them into a mesh, and in each of these cells we were analyzing that specific image and being able to say, okay, this is this type or this is that other type, with that with a level of competence. Okay. Good. So that's for material sourcing and classification. Obviously, with that, the whole process became smarter and quicker. And now let's go into the planning. Now here, the idea is that you have it's also in the steel industry with a rolling mill, and the bars were cut according to some trim patterns. So the problem they were having is that organizing the patterns was not easy. So they got a lot of different orders with different lengths, and each time they were they were coming up with a trimming pattern that resulted on a material yield, and they were not sure if there was a better way to organize their orders. Plus, whenever there was a change on the orders coming, or if there was any change of priority or something, then they had to redo the calculation again. Okay. So now here's an example. We have billets, 126 meter length, each of them, and we need to produce 100 units of 12 meters, 100 units of 15 meters, and 100 units of 18 meters, and that will result in some scrap, okay, on some yield. Now here you have an example of how that could be done, and with a certain amount of yield. Now the question is, which is the best way to do this, to reduce the yield, right? You need to consider here two things. One is we need to reduce the yield, and also we want to avoid too many changes on the setup of the machines, right? Now here we found two solutions. Okay, one is this solution number one, which is 22 times this bar, 7 times this second bar, 7 times this third bar. Okay, and then we have another solution, which is this 22 times this bar and 14 times this bar. Now, what is the difference? Well, basically, the solution number two, which is the best one, results on producing 102 units of these bars of 18 meters. But since this is something that sometimes they also get an order for, it was actually better than the other solution because they had to they reduced the variability of things that they were producing, and the yield was 0. Okay, so basically here is an optimization problem, which is part of the artificial intelligence, as you know, and that is basically trying and finding the best solution by trying many of them and coming up with which is the one that results on the minimum cost, right? Okay, good. So in here we already saw, okay, we've got the order from the customer that run straight away into the ERP. We receive the material, identify which is the type of scrap that we need to produce the products. And here we trim the billets to reduce the yield and reduce the number of changes. And now we go to another stage, which is how can we predict potential quality problems? Okay, and I said here downstream because this is an example where you will see there are two different processes which are connected, and we're trying to predict which factors or which elements into the first process may cause a quality problem in the second process. Okay, and well, in the production, these guys were producing elbows for pipes, and they had a fully monitored process. And the problem they had is that they had defects on the finished product, and the theoretical models did not explain the cause of that. Okay, so that was his whole process: taking scrap, going through a melt shop, going to a foundry, and then getting the final product. And the challenge here was, how can I predict potential defect products in the final product based on the parameters of the melt shop? Okay. Now in the melt shop, they had different types of scrap. They were adding different additives to the mixture, and they were monitoring more than 200 variables. And the nice thing is that for each product that was produced, we had a perfect traceability back to the variables that were used during in the melt shop, right? And the challenge was that the percentage of defects was quite low. So there was not so many data points to relate to, even if there were many data points, but not so many with defects. Okay. So what did we do there? Well, basically we used different AI methodologies, and what the first thing we did was to group the different castings into clusters that had some similar production parameters out of those 200, as I mentioned. Okay, and we saw there were some clusters that had very few defects, while there were others with more defects. And what we were trying is, okay, how can we move from the bad clusters into the good ones? Okay, so this was actually giving the engineers an idea of which were the parameters that were affecting the quality. Okay, we did some networks also to come up to come up with some ideas of what could be done. Okay, now here you can see in general, which was the connection between the data collected on the steelworks and the data on the second stage. Okay, and at the end, what we came up is with a solution that was able to tell them, look, if you need to process this piece, the best thing is that you do it on this specific line, because this will reduce the probability of potential quality problem. Okay, and that was done with a global KPI, and this is what is being used to decide which piece needs to be processed on which line to reduce the probability of defects. Okay. Okay. Now and finally, another situation where now we have already the thing produced. Now we need to ship it. So in logistics, what can we do with AI? Well, here is a good example of something that was done, which is solving a problem which it doesn't look that simple. Now the context, we have a producer which has more than 400 references. They have a lot, a big portion of picking that they need to do, and they're shipping more than 20 trucks a day. Okay, and the problem they had is that the picking it needs to be prepared the day before the departure, and that really resulted on not many days to not much time to really prepare that properly. And then the problem on the load tracking on loading the trucks was that the dimensions of the boxes were unknown until the picking was done, which meant that they were not able to come up with a smart solution on how to load the trucks, because they didn't know that until a few hours before the truck show up. Okay. What was the situation they had is that, well, basically the data loaded from the system was done manually. So they were looking into their system and coming up with things that they need to ship. The picking was not considered on the loading of the truck, because, as I said, they were actually doing the loading apart from the picking, which meant that it was not optimal, of course. Some of the criteria they had was not met on the software that they were using to do this for the trucks. They could not say this product cannot go next to this other, or this box cannot go on top of that one, or please put all this from this customer at the end of the truck. There were some requirements they could not be fulfilled with the solution they had. Plus, the reports that they got were not really adapted to what they needed, which meant that at the end the operators were building their own Excel files to come up with the information they had and creating some Word files so people understood how to load the things, right? Okay, what we did is a system that automatically loads the data from the SAP system. It calculates the picking boxes in advance, so really telling what needs to be put where on a specific pallet or box, depending on the type of load. Uh, we did it so we kept all the requirements they had on as I was telling you, this thing of this product cannot go next to that one. So that was one thing that was considered. And also important, the optimization was coupled between routes and loads, which usually you have a software to do loading and another software to do routes. And in here, the whole thing was done together. Okay. So how that was done? Well, basically, when we were optimizing this, we started always with an empty truck, and we placed one box, okay, and that was giving us occupying some space and giving us an indicator of which was the one that had more probabilities of being within the best solution, right? And we're putting that box in many different locations and in many different positions. And then out of those, we were selecting the ones that were more likely to be successful. And then we were placing the second box with different alternatives and doing so and so and so until we got to the final optimal cargo for the truck. Okay. All that resulted on a solution, which is what you can see here. Is in this case, it was a desktop software, which allows them to look at the picking with the different items put into the pallet with their distribution, and also getting the report that they needed to know for the people to do the picking, to tell them what needs to be put where and in which sequence. And this is done automatically, of course, based on all the things that need to be shipped on a specific date. And then all those pallets were combined into the truck. Within the truck, we have all the different packages, and then we have the route that the truck needs to follow. Also with the colors. Now these two diagrams are not, they don't go hand by hand, because in here you should be able to see all the colors that you can see here. Basically, each color here represents a different customer, so you could see which are the routes that need to be done to reach specific customers across Europe. And the nice thing of this is it's optimized, and you can be sure that in case there is any change, you just push a button, and in less than a minute you get a new solution. You can arrange the whole thing and make it fit, and then you get the nice report that it can be, well, it's needed both for the people preparing the picking and also for the people loading the truck, so they know what needs to be loaded where and in which sequence. Okay. Good, so that's it. That's pretty much what I wanted to explain you. Here you have some of the customers that we've been working with, and now I would be more than happy to answer any question you might have. Okay, thank you very much.